Welcome to Supernova. In recent years, blockchain has been a buzzword in the tech industry and beyond, promising to revolutionize various industries. However, with this rapid development comes a significant environmental concern: the energy consumption associated with blockchain. In this video, we will explore the environmental impact of blockchain technology, the factors contributing to it, and potential solutions. Blockchain is a decentralized digital ledger that stores transactions across a network of computers. To secure the network and validate transactions, blockchain uses a consensus algorithm that requires extensive computational power. This process is known as mining and is essential to the functioning of blockchain. However, mining requires massive amounts of energy, leading to significant carbon emissions and environmental damage. Blockchain is a decentralized digital ledger that serves as a record-keeping system for transactions. Unlike traditional centralized databases, blockchain operates on a distributed network of computers, often referred to as nodes. Each node has a copy of the entire blockchain, ensuring transparency, security, and immutability of data. In a blockchain, transactions are grouped into blocks and added to the chain in a chronological order. Each block contains a unique identifier called a hash, which is generated using cryptographic algorithms. This hash ensures the integrity of the block and its data, making it virtually impossible to alter without detection. The decentralized nature of blockchain means that there is no central authority controlling the system. Instead, consensus mechanisms are used to validate and confirm transactions. Different blockchain networks employ various consensus mechanisms, such as proof of work, POW, or proof of stake, POS, to achieve consensus among network participants. Once a transaction is recorded on the blockchain, it becomes permanent and cannot be modified or deleted. This immutability ensures the trustworthiness and integrity of the data stored on the blockchain. The transparency, security, and decentralized nature of blockchain provide numerous benefits, enabling secure and efficient transactions, eliminating intermediaries, and fostering trust among participants. Blockchain is a powerful technology that has the potential to transform how we record and verify transactions. Its decentralized nature and cryptographic security make it a reliable solution for various use cases, ensuring transparency and trust in digital interactions. According to a recent study, the annual energy consumption of Bitcoin mining alone is comparable to that of a small country, such as Argentina or Sweden. This high energy consumption is mainly due to the proof of work, POW, consensus algorithm used by Bitcoin and many other cryptocurrencies. The POW algorithm requires miners to solve complex mathematical puzzles to validate transactions and earn rewards, which consumes a vast amount of energy. The high energy consumption associated with blockchain technology, particularly in cryptocurrencies like Bitcoin, is primarily attributed to the proof of work, POW, consensus algorithm. Proof of work is a consensus mechanism used in blockchain networks to validate and confirm transactions. Miners, who are participants in the network, compete to solve complex mathematical puzzles in order to add new blocks to the blockchain and earn rewards. This process requires significant computational power and energy consumption. In the POW algorithm, miners must find a specific hash value that meets certain criteria. They repeatedly make attempts by generating different hash values until they find one that satisfies the requirements. This process is computationally intensive and requires substantial energy resources. The difficulty of the mathematical puzzles is dynamically adjusted in the POW algorithm to maintain a consistent rate of block creation. As the computational power of the network increases, the puzzles become more challenging, requiring more energy to solve. Miners often employ specialized hardware, such as ASICs, application-specific integrated circuits, which are specifically designed for efficient mining but consume a substantial amount of electricity. The energy consumption associated with POW has raised concerns about its environmental impact. Mining operations consume electricity, which often comes from non-renewable sources, leading to carbon emissions and contributing to climate change. The more participants and computational power in the network, the higher the energy consumption and environmental impact. Efforts are being made to explore alternative consensus algorithms that are more energy efficient, such as proof of stake, POS. POS eliminates the need for miners to compete in solving computational puzzles and instead assigns block validation rights based on the participants' stake in the network. This approach reduces energy consumption significantly and addresses the environmental concerns associated with POW. The high energy consumption in blockchain technology, particularly in power-based networks, is primarily driven by the computational requirements of the consensus algorithm. While POW has proven to be effective in ensuring network security, its environmental impact has led to the exploration of more energy-efficient alternatives like POWs. Finding a balance between security, efficiency, and sustainability is crucial as blockchain technology continues to evolve. Another factor contributing to the environmental impact of blockchain is the energy source used to power mining operations. The majority of mining operations are powered by non-renewable energy sources such as coal and natural gas. These energy sources are not only environmentally damaging but also contribute to global climate change. The environmental impact of blockchain technology is not solely determined by the technology itself, but is influenced by the energy source used to power the blockchain network. Blockchain networks, especially those utilizing the proof of work (POW) consensus algorithm, can consume a significant amount of energy. This energy consumption is mainly attributed to the computational power required for mining and validating transactions. However, the environmental impact of blockchain technology depends on the source of the energy used to power the network. If the energy comes from renewable sources such as solar, wind, or hydroelectric power, the environmental impact is relatively low. Renewable energy sources have a lower carbon footprint and contribute less to greenhouse gas emissions compared to fossil fuels. Conversely, if the energy used to power blockchain networks is derived from non-renewable sources like coal or natural gas, it can have a more significant environmental impact. These sources generate more carbon emissions and contribute to climate change. It's worth noting that the energy mix for blockchain networks can vary depending on geographical location and the choices made by network participants. Some blockchain projects are conscious of their environmental impact and actively seek to use renewable energy sources to power their operations. Efforts are also underway to develop more energy-efficient consensus algorithms, such as proof-of-stake (POWs), which require significantly less energy compared to POW. POWs algorithms assign block validation rights based on participants' stake in the network rather than relying on energy-intensive mining computations. This shift to POWs and other energy-efficient consensus mechanisms can help mitigate the environmental impact of blockchain technology. In conclusion, while blockchain technology can consume substantial energy, its environmental impact ultimately depends on the energy source used. Embracing renewable energy sources and developing more energy-efficient consensus algorithms can significantly reduce the environmental footprint of blockchain and contribute to a more sustainable future. Despite the negative environmental impact of blockchain technology, there are potential solutions. One solution is to transition to more energy-efficient consensus algorithms such as proof-of-stake (POWs), which require significantly less computational power and energy consumption. Additionally, utilizing renewable energy sources such as solar, wind, or hydropower to power mining operations can significantly reduce the carbon footprint of blockchain. The primary factor contributing to the environmental impact of blockchain is the energy consumption associated with the proof of work (POW) consensus algorithm, particularly in cryptocurrency mining. This energy-intensive process has led to concerns about carbon emissions and the overall sustainability of blockchain networks. However, it's crucial to consider the broader context. Many traditional industries and systems also have significant environmental impacts. For example, the energy consumption of the banking sector, which blockchain technology has the potential to disrupt, is not negligible either. By introducing efficiency, transparency, and decentralization, blockchain can contribute to the reduction of environmental harm in various sectors. Furthermore, efforts are being made to address the environmental impact of blockchain technology. While blockchain technology does have a negative environmental impact, there are efforts being made to address and mitigate these concerns. Transitioning to energy-efficient consensus algorithms, utilizing renewable energy sources, and promoting responsible practices within the blockchain community can help reduce the ecological footprint. By considering the long-term sustainability of blockchain applications and embracing environmentally conscious approaches, we can work towards a more sustainable and responsible future for blockchain technology. In conclusion, the environmental impact of blockchain technology is a significant concern that needs to be addressed. While blockchain has the potential to revolutionize various industries, it should not come at the cost of environmental damage and climate change. It is essential to transition to more sustainable and energy-efficient solutions such as proof-of-stake and renewable energy sources to ensure a greener future for blockchain technology. Thanks for watching. Subscribe to our channel for more video like this. We will see you in another one.